Welcome back to EduTube. We've covered a lot of important concepts so far. In this video, we'll dive into independent and dependent events, the multiplication theorem for independent events, and marginal probability. If you've followed our previous lectures, you already know that we're preparing for your final term exam in MATH001. So, let's make sure this content is crystal clear for you. 1. Independent and dependent events. Before we go into the multiplication theorem and marginal probability, let's first understand the concept of events. Two events are independent if the occurrence of one event does not affect the occurrence of the other. In simple terms, knowing that one event has occurred does not change the probability of the other event happening. Example: flipping a coin and rolling a die. The outcome of the coin flip doesn't affect the outcome of the die roll. Mathematically, we say that two events, A and B, are independent if P, A intersection B, equals P, A, asterisk phosphorus monoboride where 1. P, A intersection B, is the probability of both events A and B occurring. 2. P, A, is the probability of event A happening. 3. Phosphorus monoboride is the probability of event B happening. Two events are dependent if the occurrence of one event affects the occurrence of the other. In simple terms, knowing that one event has occurred changes the probability of the other event happening. Example: drawing cards from a deck without replacement. The probability of drawing a red card changes after you remove one red card. Mathematically, we say that two events, A and B, are dependent if P, A intersection B, equals P, A, asterisk P, B, A, where 1. P, B, A, is the conditional probability of event B happening given that event A has already occurred. 2. Multiplication theorem of probability for independent events. The multiplication theorem helps us calculate the probability of the intersection of two or more events. If two events A and B are independent, the probability of both events occurring together is simply the product of their individual probabilities. P, A intersection B, equals P, A, asterisk phosphorus monoboride. Example: if you roll a fair die, event A, and flip a fair coin, event B, the probability of rolling a 4 and getting heads on the coin flip is P, A intersection B, equals P, 4 on die, asterisk P, heads on coin, equals 1/6 asterisk 1/2 equals 1/12. If the events are dependent, the probability of both events occurring is calculated by considering the change in probability of the second event due to the first event happening. The formula becomes P, A intersection B, equals P, A, asterisk P, B, A. Example: if you draw a card from a deck and do not replace it, the probability of drawing two red cards consecutively is P, red first card intersection red second card, equals P, red first card, asterisk P, red second card, red first card. 3. Marginal probability. Marginal probability refers to the probability of a single event occurring, regardless of the outcome of other events. It is called marginal because it is obtained by summing over the joint probabilities of the other variables. P, A, equals sigma P, A intersection B, where 2. P, A intersection B, is the joint probability of events A and B. 3. The summation is over all possible values of B. Example: if you roll a die and flip a coin, the marginal probability of rolling a 4 is the sum of all probabilities where the die shows 4, regardless of the coin flip. Quick revision to summarize everything we've learned in this lecture. 1. Independent events are events that do not affect each other's probabilities. 2. Dependent events are events where the occurrence of one affects the probability of the other. 3. The multiplication theorem helps calculate the probability of multiple events occurring, with different formulas for independent and dependent events. 4. Marginal probability gives the probability of a single event occurring, ignoring the other events. Conclusion: that's a wrap for Lecture 32. Party popper, we've covered a lot of ground on independent and dependent events, multiplication theorem, and marginal probability. These topics are essential for your final term exam, so make sure you've understood everything thoroughly. Before we end, I want to remind you to check out our mock exam video, where we go over a set of practice questions based on what we've learned. This will help you test your understanding and ensure you're fully prepared for the MATH001 Final Term exam. Glowing star, don't forget, your exam is right around the corner, and reviewing the previous lectures will make a huge difference in how well you perform. If you haven't watched the earlier lessons, I highly recommend you do that to complete your exam prep. If you found this video helpful, don't forget to like, share, and subscribe to EduTube. Cell phone with arrow, hit the bell icon to get notified whenever we upload new content. On EduTube, we make exam preparation easy and break down complicated topics into the simplest explanations so that you can crack your exams with confidence. Good luck with your studies, and remember, keep practicing to ace your MATH001 final exam. You've got this.